Okay. Now, first I will discuss the way a pack of wolf hunt its prey. How? First thing you must remember is that wolf always stay in a pack. That means there will be multiple wolf in a pack, and they stay in a pack, they hunt in a pack, and they also eat its prey in a pack. Pack means multiple wolf in one group. Now, how they hunt? First of all, there is a clear hierarchy in the group of wolves. Here, the most fittest wolf is referred to as alpha wolf. He is the leader. The next most fittest wolf is referred to as beta wolf. And the third most fittest wolf is known as delta wolf. And all other member of the pack is known as omega. So what happened is that at the time of hunting, all these three wolves leads the pack, and then what happens once the alpha wolf detects a prey. So the prey is cow, prey can be deer, prey can be any herbivores, but wolf, one thing to note here is that even if there are multiple preys, that means suppose in a deer pack of deer, there are multiple deers. In a say, what I'll say, uh, there will be multiple number of members in a pack of herbivores. Even though there is a multiple number of members in a pack of herbivores, the wolf always identify or single out one prey. That means one deer from the pack, or one buffalo from the pack, or you can say uh, one mongoose from the pack. So whenever they kill only one, even if there are multiple options. And which one they select? They select the fattest prey because the that prey will have more meat and it can be easily fatigued. So it will be an easy kill for them. As you know, the more fat you have, more energy you will lose while running or walking, and you get easily fatigued. And if you are fatigued, then you cannot move. So when you cannot move, you are a very easy prey. So anyone can catch you then. So this same theory is followed here also. So now what happens? Whenever the pack of wolf detects a prey, the alpha wolf decide which one to chase. And once it decides it tries to chase it. And at the time of chasing, it actually teases it. Tease means it creates a situation where the prey, by seeing the incoming wolves, it gets frightened and it starts to run here and there. And by this way, it actually loses energy, and as it loses energy, it becomes fatigued. And after some time, it cannot run. When it cannot run, or when it is unable to run due to the lack of energy, at that time what happens is alpha male starts to encircle the prey. followed by the beta, then gamma, and then the other member of the pack. And once it encircles it and the prey becomes entirely fatigued due to the exhaustion and due to the running, and by seeing the pack of wolf encircling itself, what happens is it stops to move. It neither run, neither walk, it just stays there. And at that time, the alpha wolf pounds on it and kills it, followed by the beta, delta, and all other wolves. And then they starts to devour it, starts to eat it. So, this is the way a pack of wolves hunt a prey. First, it detects the prey at a distance. If there are multiple prey, they select only one, which one is the fatter, and then it starts to chase it. And when it chases, it doesn't kill it, it just chases. And this chase is also led by the alpha wolf, followed by beta, followed by delta, and then the other members of the pack. And when it chases it, it actually teases it. When it chases the prey, it actually teases the prey. Teasing the prey means the prey just run here and there, and ultimately it loses energy and it becomes fatigue. Once it becomes fatigue or slows down its running and ultimately stops running or moving, it just becomes standstill. At that time, what the lead wolf do is, or the alpha wolf do is, it start to encircle it, and it is followed by beta, delta, and all other pack. And when it encircled it and the prey also become totally fatigued, it cannot move, then it pounds on it and kills it. Now this entire procedure is led by the alpha wolf, and it is followed by beta and delta and all other members consequently or sequentially. Now this is the way the wolf hunts. Now if you want to mimic it to find the best solution to a optimization problem, then the prey will be your most optimal solution, and the pack of wolf or the member of a pack of wolf will be your other solution. Okay, within those solution also the alpha wolf will be that solution which is the most fittest. Beta will be the next most fittest, and delta will be the next most fittest. That means most fit is alpha, okay, followed by beta, followed by delta, and then the remaining members. But even if the alpha is the most fit solution, your prey will actually be the better solution, better solution than the alpha wolf solution. Okay, so let me explain first. Say for example, this is the domain, feasible domain from where you can collect solution for the optimization problem. Take the example of my old problems. Y is equals to x square. You have to maximize y by changing x, but x can be a value which lies between 1 and 2, but it will never be, it cannot be equals to 1, equals to 2, but any number in between 1 and 2. So you see here, if this is the x-axis and this is the y-axis, then if this is the y-axis and this is the x-axis, what will happen? This will be your feasible domain, this area. From here only you can take the values of x. It can be 1.1, it can be 1.8, it can be 1.7, but it cannot be 1 or 2. But among all these feasible solutions, which one will be the most feasible? That will yield the maximum value of y. This is the problem. As all of you know that x is in this case called as or referred as dv, design variable, and y is equal to x square is your objective equation. X is design variable, you know, 1 and 2 is the constraints, right? These things, you know, this is this area 1 which is restricted by 1 and 2. This is known as the feasible domain, and this outside of this feasible domain is the infeasible domain. And you can collect solution, that means collect values of x only from the feasible domain. And here you must, this is graphically I am showing this, but actually your physical domain is this only. This is the area from where you can collect the values of design variable, and by putting those values into this objective equation, you can find the value of y. And once y become maximum, you note down the value of x in that case. Then at that value of x, y become maximum. So at that value of x is your most feasible solution among all the solutions that exist within the domain. Now, if you want to mimic the way a pack of grey wolves hunt a prey, what you have to do? First, you have to consider that your prey is the most feasible solution, most optimal solution, followed by the alpha wolf, right? Then alpha wolf is followed by beta wolf, delta wolf. So the fittest solution among all the solutions available is the prey. It is being followed by the alpha wolf, which is the next best solution, then beta, that is the next best solution, then delta, next to best solution. I think you can understand. That means the most fit solution will be the prey, followed by the alpha wolf, followed by the beta, then delta, and then your other omegas. Now here, you know, at the time when the problem or iteration or the algorithm finds the most optimal solution of a problem, at that time the prey becomes the alpha wolf. And by alpha wolf, what we want to represent is that the position of the solution in the feasible domain. Suppose I indicate the prey by a circle and indicate the other solution by cross, because I don't know which one among these other solution will become the most optimal solution. To know that, we have to use a fitness function that is nothing but the y, because whenever y at the present iteration is higher than the y at the earlier iteration, then you are having, or you have identified, a better solution compared to the previous solution. And the solutions are the values of x. Okay, I hope you understood. Now let us come to the mathematical equations. So here what happens is this d, you come to this part. This d is the distance between x alpha and x prey. That means x prey means the position of prey, that I have already said assumed to be the most optimal solution, indicated by the circle, and x alpha is the next most fitted solution, that means the nearest solution. Okay, now what happens at the first iteration, that means I is equal to 1. Here iteration is indicated by t, so it is better to use t instead of I. So at t is equal to 1, first iteration, what happened? You try to find the distance between x alpha and xp. So how you found it? C dot xp minus xt. Okay, so here I told the incorrect notation. Here this x is actually your position of prey. So this is not xp. Basically xp is your x alpha. Sorry. Okay. Okay. So the distance between the x alpha or xp from the prey can be represented or can be estimated by d equals to c dot x. This x here is nothing but your position of the alpha wolf or x alpha minus x. X is the position of your prey. Okay. Now what happened? Now what you will do is that you will try to find a new solution for this problem. This is the first solution, or the first position for the first iteration. Now you will say how I can identify in which location or which position the solutions are at the first iteration. So that is why we take randomly 4 to 5 solution of x, and we try to represent it by this x's with a vector. That is why this is a vector. If it is a multidimensional, multiple x, then what happens? It becomes a vector. So that is why all these are in a notation of vector, because there can be multiple solution or there will be one solution. For easiness of the explanation, I am assuming that there is only one solution. That means I am generating randomly only one solution. Okay, and another solution is generated for the position of prey. So my first step is that choose two numbers randomly from the feasible domain 1 to 2. That means within 1 to 2 I can select any value randomly. So I select one to be 1.1, another to be 1.9. This is selected randomly. Now your next question will be, which one will be the position of prey, which one will be the position of alpha? Right. So I have said that position of prey is actually your most optimal solution. So in this case, as this problem is very simple, y is equal to x square, you can easily understood that at 1.99, at x is equal to 1.99, y will be maximum. That can be easily assumed because this is a unidirectional, one-dimensional problem. You can easily assume that at the maximum value allowed for x, y will be maximum at that point only. Correct? So within 1 to 2, x cannot take the value of 1 or the value of 2. So certainly the just below 2, the number just below 2 will give you the maximum value of y. Correct? So if I randomly selected 1.1 and 1.9 to be the first, to be the position of feasible solution at the first iteration, then 1.9 is certainly nearer to 2. The and we are planning for maximizing y, so certainly 1.9 will yield a higher value of y compared to the when x is equals to 1.1. So assume 1.9 to be the prey and 1.1 to be the alpha. Correct? So now the next iteration, what will happen? So at the first iteration, we find the distance between xp, that is x alpha, that is 1.1, and x, that is the position of prey, which is 1.9. So here only one, I have generated only one random solution for alpha and one random solution for the position of prey. That is why what will happen is, there is only one x representing alpha, another x representing prey. So the C will also be one dimensional. Correct? Now what is this C? C is this 2 dot R2. This dot indicates actually piecewise multiplication. If there are multiple x's, then you have to multiply it as many x you have. So, and what is R2? R2 is nothing but random number. Random number means any value in between 0 to 1, but fraction. You multiply it with 2, whatever may be the value, this becomes C. You put it in C, then this dot is actually pairwise multiplication. So here only one value is there. So this is actually multiply. This is actually multiply, not dot. This is actually multiply also. So what you do, you multiply the random number with 2, place it here as C, multiply with the randomly selected position of x 1.1 here, because this is the alpha male, position of alpha male or alpha wolf, and you deduct the position of prey 1.9 from this. Now to find the new position, right, to find the new position of x, then in the next step what you will do is, here you see x t plus 1 means next iteration. So at x at t plus 1 will become xpt, that is this one 1.1, minus a dot d. A dot d means a multiply d, because that I have already explained. Because here I am using only one x. If you use multiple x, then it becomes a dot d, becomes a pairwise multiplier. So A dot D, what is A? A is equals to 2A dot means multiply R1 minus A. This R1 is again another random number. R2 is random number, R1 is random number. R1 is also any value in between 0 to 1. Okay. So, and this A is, as you see, A is decreased from 2 to 0. That means that first iteration you take A as 2. In the next iteration you take A as 1.99. In the third iteration take 1.98 and so on. Basically, this A is a random value between minus 2A and 2A. This I will explain later on. But practically speaking, you generate a random number, multiply it with 2 into, for A, you use any value in between 0 to 2. But first of all, you have to use a value which is nearer to 2, not a value nearer to 0, because the value of A will decrease with iteration, not increase or increase, decrease, not that. It will decrease, it will follow a decreasing trend. Okay, so 2AR minus A, this will be your A, and C is, I already discussed, 2R. So once you put the value of A here, D, put the value of D here, then you deduct these two, A into D, from XPT, the value of the X alpha, or the location of X alpha, or the value of X alpha, it is better. That is more correct. And that will give you the value of the new X alpha. Value of the new X alpha means position of the, or the new position of the alpha wolf. And then what happened in the third iteration, or in T plus 1 iteration, this XP will become XT plus 1 suddenly, but this one will remain as it is, and by that way you find the distance again, and then you put the D here, generate the value of A, deduct it from the value of XP, or the position, the value of XP means the location of the new location of alpha wolf, right? To find the another new location of the same alpha wolf, that means T plus 2, right? So you see X T plus 1 you have generated. With the help of X T plus 1 you will generate X T plus 2. With the help of X T plus 2 you generate X T plus 3, and so on. But the basic step is that first you will find the distance between the position of alpha wolf indicated by X subscript P, that is nothing but a random value in between the feasible domain of X, that is between the 1 to 2. I have randomly selected 1.1, and as it 1.1, and you will select another value which will indicate the position of your prey, the most optimal solution. I have selected as 1.9, and this 1.1, that means that this position of this solution, what we are referring as the position of alpha male or alpha wolf, at every iteration you will try to reduce this distance. That is your goal. At the moment when the distance between the position of XP and position of XT become minimum or 0, that is the moment when you will find the most optimal solution that is possible within the domain of feasibility, or the feasible domain for this problem, and at that solution only Y will give the maximum possible value it can produce. And this is a iterative procedure. You have to constantly iterate until the maximum number of iterations that you have decided at the beginning of the program is exhausted, or the difference between this and this becomes 0. Right? So this step is known as the teasing step. You see, here I am using only one solution, which is I am referring as the location of alpha wolf, and another solution which I am referring as the position of prey, because I have assumed that the position of prey is the most optimal solution possible for this problem. And then what happens? You are trying to find new locations, that means new values of x, with the help of this equation at every iteration. T plus 1, T plus 2, T plus 3. Here T is the number of iteration that I have already discussed. And we begin from T is equal to 0, so and so on. And here two coefficients are used, A and C. A is determined by this 2 small a multiplied by R1 minus small a. Now this R1 is a random number, any value in between 0 to 1. Or I will say not value, I will say any real number in between 0 to 1. And A is a value which lies within the 0 to 2, but it is randomly selected, and with every iteration the value of A is decreased, not increased, or not randomly changed. Clear? So whatever value you will select for this A, the same value will be used for this A. And your C will be equals to 2 multiplied by R2. R2 is your random number, another random number, same any real number in between 0 to 1. Okay, so this is the teasing step. Now this teasing step, at the initial juncture, I am showing for only one x, correct? The moment you use 2 more x, then you are introducing the beta wolf and the delta wolf. And if you are generating multiple number of x, then after the 3x, that is yielding the most fitted solution. Remember my discussion, as I have said, alpha wolf is nothing but the position of the solution having the most optimal y. That means maximum y. The value of x that I am indicating, if it yields the maximum value of y among all the x's, all these 3 x's or all this n number of x's, the value of x which is yielding you the maximum value of y, that will be your position of prey. But that next value of x that is yielding the next highest value of y will be your position of alpha, followed by beta, followed by delta, and then again, right? So first I have explained it with only the alpha x, but you can also use the beta x and delta x and also the omega x. And if you are using multiple x's, then to find the new values of x at t plus 1th iteration, you have to find the average value of all the x's that you have selected. Pardon, not all the x's that you have selected, only those x's which are giving you the most fitted value of y after that value of x which is giving you the best value of y, because that is reserved for the position of prey. That you cannot change. That will remain as it is. Correct? So when you are using multiple x, suppose 50 number of x you selected randomly, then one by one you put it into the y is equal to x square. They will give you the value of y. Then rank them in a descending order and note the value of x for which the y is maximum. So that will be your position of prey, followed by position of alpha wolf, followed by position of beta wolf, followed by position of delta wolf. Neglect all other values and you move ahead with these three values. Now you will say that, okay, by putting the value of x's, random values of x's, I am already generating the maximum value of y. Then what is the reason I will use this optimization algorithm to find that value of x for which y will be the most optimal? My question is that the initially that you are doing, that means randomly selecting 50 number or 100 number of x and putting each x to your equation y is equal to x square, and you are arranging them in a descending order of y, and by this way you are identifying the value of x that can be used as the location of prey, followed by the location of alpha, followed by location of beta, followed by location of delta, and you can neglect all the other 46, or if you have selected 50 random x, if you have selected 100 random x, then you neglect all the remaining 96 number of x. This is not now this is just like a linear algorithm. May or may not be the value of x which is indicating the position of prey, may or may not yield you the best solution. It may change at the time of iteration. Okay, so what you are doing is that first you are doing it linearly, and when you are implementing the algorithm, you are doing it meta heuristically. Okay, and that is why now you'll say that how it is possible, because I am using the same x. I will say no. In the new iterations, you are not using the same x's. First of all, you are neglecting all those 96 x's that are unfit. You are moving ahead with the three best fitted x's, because the better solution of x is already earmarked for the position of prey. And whenever you are using this average of x, you are generating new values of x which you have not included at the initial selection of x's. But when you are initially selecting 100 number of x's randomly from the feasible domain, you are not selected the average of x1, x2 and x3. Correct? So you cannot say that this the x that is coming out in t plus 1th iteration, that x you have already considered. No, you have not considered. That is why I am using an average. Okay, so in this way also what happened, a type of mutation is taking place. Mutation in genetic algorithm is known as introduction or generation of a new trait. So you are actually, by averaging these x's, you are actually generating a new type of x. Now I have said that I will discuss about this 2a to 2a, minus 2a to 2a in the end of the explanation. You know, this a is actually a domain of your search domain. within this feasible domain, and it varies between -2 to 2. So if you are generating some value which is moving towards this direction, it said that you are trying to find a new domain. Matlab, you are trying to expand your search domain. Although you cannot overtake the domain bounded by your constraints, you cannot do that. But what you can do is that when you are moving towards the new tool, you are expanding the domain. And this is known as exploration. Okay, and by this way you are also avoiding the local minima. After some time you will see that even after doing this average, you are getting the same values of x or same type of x, which will by putting into the equation y is equal to x square, it will not give any better solution. So at that time you have to change the domain, you have to change the or expand the domain. So you have to move towards the this one, this way. But if you are moving towards this way, you are actually doing an exploitation. That means within the same domain, you are trying to find different solutions. But this is not very important concept. This is not required also. If your only objective is to find the best solution for your optimization problem, then it is enough to know this teasing phase, and yes, this is known as encircling phase. I told you now, first it teases the prey, fatigued it, and then it tries to encircle it. And after encircling, it is the time to kill. So only if you encircle, then only a new mutation, new type of access will generate, and then only you can converge into the most optimal solution. So with this, I finish this lecture. For any question, you can comment to my video, and I will try to answer as much as I can. Thank you and goodbye.